So today we're going to be using properties of integrals and geometry to find the value of this integral. So it's the integral that goes from 0 to 3 square root of 9 minus x squared minus 5 times the absolute value of x dx. So for our solution here, we're going to start off by using a property which says that if you find the integral from a to b of a sum of two functions, it's equal to the sum of the integral. So integral from a to b f of x plus or minus g of x dx equals the integral a to b f of x dx plus or minus the integral of a to b g of x dx. Okay, so it could be adding or subtracting. This is dependent, though, as well, that both the integral of f of x and g of x exist, okay, which is the case here, so we won't have an issue. So we're going to apply this property with our problem, and essentially what I'm going to do is I'm going to just simplify this as 0 to 3 square root of 9 minus x squared dx minus the integral from 0 to 3 5 times the absolute value of x dx. One more property of integrals that we're going to use here, which is the following. If you have a constant in front of your function, you're integrating from a to b, you can factor the constant out and then multiply by the integral from a to b of f of x. So in our case, this is going to be 0 to 3 square root of 9 minus x squared dx minus, and I'm going to factor the 5 out of the second integral. And there we go. Okay, so we'll only use that property in the second integral. And I just put a 5 there accidentally, sorry about that. So we factored the 5 again. Now, this is where we're going to use geometry. We're done using properties of integration here. Now it's time to use geometry. And the way we're going to use geometry here is to look at these two functions inside the integrand and see if we can get a picture of what they look like. So if you look at that first integrand, the function y equals square root of 9 minus x squared, let me write that out as such. Now we square both sides, you get this, and I could add the x squared over. Now the reason I did all of this right here was so I can identify what this function looked like. Sometimes you can't identify a function right from the start. You have to do a little more operations. In this case, my operations were squaring, adding things over. And what this is telling me is that this function is essentially part of a circle, okay? This equation, x squared plus y squared is 9, is the equation of a circle of radius, let's say 3, so it looks something like this. And furthermore, we're only looking at the top half of the circle. Why? Because y equals the square root of that, and there's no sign, but it's positive. The only things that come out of a square root are positive numbers, so you're only working with this top half. And then the limits of integration from 0 to 3 tell you that you're only looking at the right-hand part of the circle. Your circle for the x values, they range from minus 3 to 3, okay, because the radius of the circle is 3, and the center is the origin. Okay. So that equation represents a circle. The square root of 9 minus x squared tells you it's the top half, and the limits of integration, the 0 and the 3, tell you it's only the right half of the top. If you had a minus in front of your square root, then you'd be looking at the bottom half as such, okay? So just make a point of that. So that integral, essentially, the 0 to 3 square root of 9 minus x squared, is equal to the quarter area of a quarter circle. So the area of a circle is pi r squared. So it's pi times 3 squared, but the whole thing, but we're only looking at a quarter of it, so it's divided by 4. So 9 pi over 4 would be the area of that quarter circle, so that's what the integral would equal. And then the next part of the problem with the absolute value here of x, the absolute value of x looks like this. So it's like a V-shaped. And we're looking at it from 0 to 3. And essentially you're grabbing the area of this triangle here. And the area of a triangle is 1/2 the base times height. So the base is 3 units. But what about the height? Well, absolute value of x gives you the y value when x is whatever. So if x is 3, then your y value would be 3, which would be the height here. So your area for this function from 0 to 3, the absolute value, would be 1/2 the base, which is 3 units, and the height is 3, so 9/2. So finally, when I compute the integral that goes from 0 to 3, square root of 9 minus x squared dx, minus 5 times the integral 0 to 3, the absolute value of x dx, this is going to be 9 pi over 4 minus 5 times 9/2. And you get 9 pi over 4 minus 45/2. And that would be your final answer. Now this would come out to be a negative number, okay? This is the exact form, and I won't really simplify it anymore. It needs to be, but it is going to be negative. And the point that I wanted to get at was a lot of people always think about an integral as an area under a curve. In a sense it is, but it's what we call a net area. So what that basically stands for is that your area can be negative because of the fact that your function, for example, goes below the x-axis. So let's say your function did something like this, and let's say this was the point, whatever, let's say this is 10. Then if I were to find the integral from 0 to 10 for this function, it would come out to be negative. Why? Because you've got the area that's above the curve, and you have area that's below the curve, but the below area has more than the above area with respect to the x-axis, so that's why that would be 0. So you definitely can get a negative value for this, okay? All right, so that is basically how you would use properties of integration. I hope this helps. Thank you for your time.